Ready, RJ? Hey guys, I'm here at the San Andreas Fault, near where the epicenter of the 1906 San Francisco earthquake occurred.
Hi guys, you must be the treehouse detectives. How can I help you?
Our friends in Virginia felt a vibration the other day, and they wanted to find out if it was an earthquake.
They said we needed to learn more about faults.
Well, a fault is a weak zone in the Earth's crust where the rock layers have broken and slipped apart. Would you like to see the San Andreas Fault?
RJ, be sure and get me on camera.
Okay. So where's the fault line?
You can see it here. See the line that goes up the wall?
Are there different kinds of faults?
Yes, there's three kinds of faults. One is called a normal fault, and that's when the fault is at an angle, and the top block is called the hanging wall, and that moves down relative to the lower block, called the footwall. And this happens where there's extension in the crust and it pulls apart.
Is there an abnormal fault?
Well, it's not really an abnormal fault, but there is a fault that's opposite of a normal fault, and that's when the hanging wall block moves up relative to the footwall block. And this happens where there's crustal compression. And those faults are called reverse faults or thrust faults.
What's the last type of fault?
Well, the last kind of fault is called a strike-slip fault, and that's like where we are now on the San Andreas Fault.
We learned that the Earth's lithosphere is broken up into plates, and the plates' movement is what causes earthquakes. But I don't get it. Are plates and faults the same thing?
Well, moving plates grind and scrape against each other at their edges, and those edges we call plate boundaries. And plate boundaries are usually made up of many faults.
Are there different kinds of plate boundaries like there are different kinds of faults?
Yes, there's also three of those. Divergent boundaries are where the crust is being pulled apart. This can form new crust or cause rift valleys and even make volcanoes. The pulling apart can happen at about 2 centimeters a year.
That's not very much. It must move really slowly.
Yeah, they do. And a convergent boundary is where the plates crash head-on.
Oh, those boundaries move slowly too.
Yeah, they do. They only move a few centimeters a year, and because it's slow, it can take millions of years for them to form. And when the plates collide, sometimes you can get large mountain chains like the Himalayas.
Wow, now I'm starting to understand why the Earth is shaped the way it is.
The last boundary is called a transform boundary. It's when plates slide past each other, like the San Andreas Fault here.
Does that mean California's not going to break off and fall into the ocean?
No, that's a common misconception. Actually, Los Angeles may someday be next to San Francisco, but that will probably take 10 million years.
That's a long time.
I don't think we have any boundaries in Virginia. Do earthquakes occur anywhere else?
Yeah, a few earthquakes occur in the middle of plates, called intraplate earthquakes. And in 1886, there was a large earthquake in Charleston, South Carolina.
South Carolina is near Virginia. Maybe they did have an earthquake.
Do you want to try making your own earthquake?
Will it knock houses down?
No, it won't be a real earthquake. It'll just be a simulation of a very small one. Let's go. I have a setup here that we're going to pretend is like the Earth's plates moving. So you're going to turn the crank and apply stress to these blocks. You're going to cause a force to be pulling them. And this is going to be the equivalent of one plate, and this is going to be the equivalent of another crustal plate. And watch as you add more and more stress and see if you can get an earthquake.
RJ? Wow, was that an earthquake?
Yeah.
Now that's my kind of earthquake. This has really been helpful. Thank you.
Sure. Well, email me if you have any more questions.
Okay.